compute the triple integral over the region R of xyz dv, where v is the volume element of R, and R is the region in the first octant inside the right circular cylinder x squared plus y squared equals 9 from z equals 0 to z equals 2. So in 3 dimensions, x squared plus y squared equals 9 is a cylinder, a right circular cylinder, that goes up to infinity and down to negative infinity, but we're only going to consider it from z equals 0 to z equals 2. So we have here the z-axis, and our cylinder is cut off at z equals 2 at the top and z equals 0 at the bottom. Now we're also only working in the first octant, so the x and y coordinates are positive, which means we're only getting 1/4 of the right circular cylinder. So we're getting 1/4 of the cylinder. This would be the x-axis here, and the y-axis is in there. And there's our 1/4 of a right circular cylinder. So it sounds like cylindrical coordinates might be helpful. So instead of using x, y, and z, we will use r, theta, and z. And then the volume element in using x, y, and z would be dy, dx, dz, and instead we will use r, dr, d theta, dz. So we'll set up the integral in cylindrical coordinates. X is r cosine theta, y is r sine theta. Those are the standard polar coordinate transformation in 3 dimensions, and in cylindrical coordinates it's just polar in x and y and then z. Just leave the z alone. And then we have a z, which will just stay z, and then dv is going to be r, dr, d theta, dz. So z is going to go from 0 to 2. Theta, since we're only doing 1/4 of a circle, theta is going to go from 0 to pi over 2. And so 0 to pi over 2. And r is going to go from 0 to the radius of our cylinder is 3. 0 to 3. X squared plus y squared equals r squared. So r squared is 3. R squared is 9, so r is 3. Okay, so this is our triple integral. This at the top here says pi over 2. And now this function is separable, meaning that it's a function of r times a function of theta times a function of z. And so we could split this triple integral into a product of 3 integrals. We could do integral 0 to 2 of z dz times integral 0 to pi over 2 of sine theta times cosine theta d theta. And then we could do integral 0 to 3 of r. We have 3 r's here, so we have r cubed dr. So the integral from 0 to 2 of z, we have z squared over 2 from 0 to 2. The integral of r cubed, we have r to the 4th over 4 from 0 to 3. And this integral, we might prefer to do u substitution, u equals sine theta, du equals cosine theta d theta. So this one will turn into the integral of u du when theta is 0, u is the sine of 0, which is 0, and when theta is pi over 2, u is the sine of pi over 2, which is 1. And so this integral turns into u squared over 2 from 0 to 1. And so altogether, this one is 2 squared over 2. Here we get 1 squared over 2, which is a half. And here we get 3 to the 4th over 4. And this is 2 times a half is 1. So the answer is 3 to the 4th over 4, which is 81 over 4. Final answer.